Alright, I need to check to see how I'm doing here. Alright, let's see. No dedicated mic. Alright, and now I'm live. Let's see. No dedicated mic. Alright. I need to check to see how I'm doing here. Alright, just had to check to see how I'm doing. I need to check to see how I'm doing here. Alright. So we do have a stream running right now. Nice. Alright, just had to check to see. So let's start this homework. Alright, let's see. Let's find the Laplace transformation for the function f. This is kind of hard to do. But let's see, f of t equals 7 where t equals, motherfucker, t is greater than 0. So the way that we do this is we actually have a table. So they give us a table for the Laplace transformations, but he did teach us how to find it without the table, but I'm just going to be using it because it's my homework and I can do it however the fuck I want. But okay, why did my screen cut out for a second? So the Laplace transformation of 7 is equal to 7 times the Laplace transformation of 1, and the Laplace transformation of 1 is equal to 1 over s. Times 7, which means that this should be equal to 7 over s. So this one's actually quite simple. It's just the and we test it out. So 7 over s, and we got that one right. All right. Now eraser will take and we'll increase the size by a lot. Okay, wait. I think I need to do this on a paint layer. Alright, paint layer. And so now here if we erase, okay, that's a lot better. Okay. Fuck that. Alright. Where the fuck is the drawing? I don't usually use this one. Oh, okay, there we go. Alright. So find the Laplace transformation of the function e to the 3t Alright, so for this one, e to the 3t, I could pull out the Laplace transformation table, but I think it's actually important that we discuss how to get them in the first place, like doing them by hand. So we'll say f equals this of t. So the Laplace transformation of f of t, I know I have shitty handwriting, but it's equal to the integral from 0 to infinity of e to the minus st of, multiplied by f of t dt. Right? So in this case, we have that the Laplace transformation of e of 3t will be equal to the integral of 0 to infinity. I feel like there's kind of a delay on here. I might be going crazy, but yeah. So you have e to the minus st multiplied by e to the 3t dt. Right? And so now this is equal to, if we take it, we go the integral from 0 to infinity of e to, in parentheses, we have 3 minus t, 3 minus s of t. So you have of t dt. And of course, it says that t has to be greater than 0. I forgot to mention that, but it says t is greater than 0. So this will all be equal to this integral. Use substitution. So for this, we'll just, you put this entire inner function as u. If you do that, you fucking ignore the people next to me, but if you do that, you get e over 3 minus s raised to the power of 3 minus s over t from from 0 to infinity. So with this, we could just pull out the constants, or I guess not constants, but we can pull these out. So we have 1 over 3 minus s multiplied by Am I bullshitting? What the fuck is wrong with me? What? No. Right. So what we can do here is we'd actually move out the negative sign. So we have e to the s minus 3 negative t. So we have 0, which means that we have 1. So the infinity here ends up being 0. So we have 0 minus plug in 0 for t, we have 1. And there was a limit here, but I skipped it because some shit's happening in real life. And then we have negative 1 over 3 minus s, which is equal to 1 over s minus 3. So we test this one out. We have 1 over s minus 3. And we double check. And we got it correct. So yes, this is how you do it correctly if you're trying to do this by hand. But we have the tables to do these a lot quicker, and these tables are very helpful for speeding things along. So I'm going to go to folder. All right, it's in my folder. All right, this is nice with the Laplace transformations, but let's erase. Where's my mouse? Okay, here it is. Increase to like very big size, the very big me. And I just like to click it a little bit on the mouse, just so that way if I undo too much, it doesn't re-put in everything. So find the Laplace transformation of f of t equals e to the point 6t, where t is, of course, greater than 0. So for this, s. Alright, so for this one we find where we get e to the at. So we have e to the a t, the Laplace transformation for this, right? Will be equal to 1 over s minus a. And because our a is 0.6, we have a equals 0.6. Then we know that the Laplace transformation of e to the 0.6t is equal to 1 over s minus 0.6. Now there's this extra parameter saying that s also has to be greater than 0.6. I don't think we're getting into the, what are they called? Let me go check my notes real quick. What they're called. Yeah, I don't think there's a step function in here, which a step function is just essentially saying that for this value, it doesn't exist, that it's 0, and for this value, it's 1. So the step function doesn't exist, I believe. So we just plug this in, and you can check to see if I'm right. Or I guess if we're right, because we're going along with it. So, yep, we got this one correct. All right. I just want to double check that my stream is going according to plan. I can't see any YouTube comments. Yeah, all right. Can't see any. Where's my mouse? Okay, here it is. Increase to like very big size. All right, so we're doing pretty good. All right. So here we lower it down to 5 should be good enough. So to find the Laplace transformation f of, so this is a unique one to having us fill this one out, but f of s is equal to the integral. We have lower bound, upper bound, and so we have the rest of the equation. So we're trying to find this for the function f of t is equal to e to the 5t, where t is greater than 0, right? So for this, they essentially just want us to write out the integral that we were doing earlier, where it's equal to from 0 to infinity, so 0, infinity. I can't see this because my screen keeps blacking out. I might have to end up shutting off stream after this and then kind of doing it the other way around, which might make it a lot easier. So we have e to the minus st e 5t dt, right? So with this, essentially this is equal to the integral from 0 to infinity e to the 5 minus s t. So, and also dt. Got to remember to have the differential there. I believe this differential, I'd be forgetting the words for it, I just remember how to do it. So specifically this program that we're doing, which I believe is MyOpenMath, connecting into our specific school's proprietary software, it just, you press 00 and it'll give you infinity. So we have e raised to the 5 minus s t. And now this is technically correct. Conventionally, it might be written somewhere else, but this is fully correct, 100% correct. Or at least it should be. We can check. The software luckily accounts for things being equal and not things being written in a certain way. So that's very nice. It's very convenient that we don't have to force us to write in a certain way. So for here, we just find the Laplace transformation, and we have the table, so I'm just going to use a table. I'm not going to do it all by hand again, of e to the 5t, where we have 1 over s minus a, which is here to be equal to 1 over s minus 5. I might have those turned around, but I believe that should also be right. So s minus 5. Yep, so that is correct. And write an inequality in terms of S in which describes the domain of F. So we have to write an inequality in terms of F, or in terms of S, that describes the domain of F. So here is, I believe, where we pull out our step function. So our step function equation here will be, I'm going to pull out the notes just to practice this. Now let's see what we can do here. All right. So for the step function, we have. So I guess I'll, because I'm doing this not just for myself, but to explain, a step function is a function u of a or u of t minus a, where essentially what it's saying is that at a is a switch. So at a and above, it is equal to 1, and anywhere below a, it is equal to 0. So for t less than a equals 0. Or actually, writing convention there is off. We have 0 when t is less than a. I'm very bad at writing. It's very inconvenient for me. but we have 1 when t is greater than or equal to a. So if we have, for example, a function, let's say we have our number line here, and then this is point A. So I'll put extra thickness here, but this would mean that if this right here is 1, then this right here is 0. What it'll look like is our step function is just saying that it looks like this. Oh, I guess right here, because that's where the 1 starts. Right? And then there'd be like an empty circle. There would be like an empty circle here, because it kind of approaches any value less than a is 0, any value over a, the function is equal to 1. All right, so if, for example, let's say we had, instead of a, we had 3, right? We had 3, right? We take out 3. Right? Right, so once you hit 3, it becomes 1, but it's 0 everywhere else until you hit 3 and becomes 1 after. So this actually took me, for some reason, a minute to figure out. I was going ahead of the class a little bit, because for some reason I was just locked the fuck in. But yeah, it took me a moment to figure that out. So essentially, I believe what this question is asking is, imagine a step function that obeys our domain of t being greater than 0, which means that it wants us to write this as f of t, where is equal to e to the power of 5t, where t is greater than 0, is analogous or equal to the situation where we have u0. So we have u0 times e to the 5t. So this is actually kind of interesting. So the way that we would solve this is the Laplace transformation for, because we have an equation here, so Laplace transformation of a function u of a multiplied by f of t minus a is equal to e to the minus as fs. And if you don't know, fs is just our function after it's been transformed Laplace-ly. I don't know the vocabulary for this. I just know how to do. I just know the basics. All right. So, in other words, we kind of want to rewrite this. We want to rewrite e to the 5t to being equal to some number, let's say p, times, or some number or function, e to the 5t minus 0, right? And if you have this to I, the 0 doesn't really do anything, right? Because it's 0. So this is just equal to p being 1. So we just have it as equal to e to the 5t. Luckily, we didn't have to do much here. And so we get e to the 0 is just equal to 1. And so I think I might have done this wrong. Okay. So, okay. Everything here is technically right, but it's not answering the question. Everything I'm doing here is right. And it doesn't change. Yeah. So everything I'm doing here is technically right. And what it's doing is this integral right here is saying that it starts at 0. If I were to do it with a number bigger than 0, it would change the lower bounds, which is why it would affect the total thing. But I think here I'm just going to give it a guess, and I'm going to say 0, just because it's for t greater than 0. Oh, yeah, let me just put s greater than 0. All right. Yeah, so I got the last one wrong. I don't know how to do this. Write an inequality in terms of s, which describes an domain of f. So oh, okay. Sorry. So it says we're doing standard rules. So standard rules are basically just 1 over s minus 5 means that s cannot be equal to 5. So, okay, that should work. All right, I guess I'm okay. Wait, what if I put s is greater than 5? I'll just put s is greater than 5. Okay, there we go. I guess we can't do negative. I forget why. Or if that's just a product of the program that we're using. So that was a little much. Let's go ahead. Let's erase all this. Right. So we'll start from the top and work our way down next time. All right. You know what? Fuck that. We're gonna do a little drawing break. All right. So what should I draw? Maybe I'll draw a person with a hat. So we have, let's get rid of the eraser. And let's kind of do it kind of thin. All right, now let's kind of like figure out this kind of circlish form because I'm trying to work my best with the imprecision that we have. And that's kind of a really big example of why that's such an imprecision. And then making this kind of curve this way is kind of difficult. I'm not an artist or anything, I'm not crazy, but I think a drawing book is fun because I used to draw. I don't draw as much, but we take this shape right here, right? And so do a little drawing, right? Okay, my screen fucking blacks out all the time. Jesus fuck. Alright. This is like an old monitor. Like a little cowboy hat, kinda. Alright. So, alright, let's. Alright, let's give a little length to this side now. Alright, let's go for a bit thicker of an eraser. So we go here, right? Hmm. I'm kind of bleeding in too much. I don't know if I want to commit to that erase. Alright, so now go with the neck. The neck I think I usually am pretty good at doing, so we start from here. Right, little guy with the cowboy hat, and then we do the action neck here. Right, and so we have collarbone, dude. Right, okay. So kind of collarbone can start from there. Maybe we spread it out like just. All right, this is looking kind of good. Like this is looking kind of bad. All right, wait, okay. All right, wait, all right. Let's connect here. Maybe we have some decent shoulder muscle. Right, and then we make a little like round size like for the shoulders, right? So we're making a big man. We're making a big buff man, right? Making a big buff guy, right? And so maybe we draw a line here, place to connect this torso. You know, I'm not gonna place too much emphasis on making him not deformed because I'm using a fucking mouse. You know what? Let's make him wider. Let's make him wide. Let's make him big and wide, like a box. That's fine. That's totally fine. Okay, so we have Buddy Boy. Let's give him some fucking legs, bro. Let's make a okay. Wait, let's. I think flannel. This guy likes flannel. Let's make him flannel. I don't know how to draw flannel, but I could try. And my vision just cut out. Okay. It's the monitor. I know it's not the computer. It's the fucking monitor. I mean, okay, I just ooey. This is ooey. All right. think I'll go and erase now. All right. So now from here, where do we go? All right. Next question. Let's see. Find the Laplace transformation. F of s is of the function f of t equals t to the power 4, where t is greater than 0. So this one's actually pretty easy. There's not much to show if I use the table, but yeah. So we have f of t is equal to t to the power of 4, t being greater than 0, but that doesn't matter. All right. So for this one, I think I'll tell you which property or which Laplace transformation on the table it is. Let's see. The Laplace transformation is t to the n. So let's see. So you have the Laplace transformation of t to the n is equal to n factorial over s to the n plus 1. So it's s to the n plus 1. Specifically, if n is an integer, so that'd be I think it might actually mean if n is a natural number. Actually, no, it doesn't. It would have to be positive. Positive integer. I'll say positive integer, right? And this positive integer. This could be wrong. Also, I think I have this backwards. I think n can just be, I think it's the other way around. So yeah, as long as n is a positive integer, this should work. So in this case, n is 4. I know it's a shitty ass 4, but n is 4. Which means that the Laplace transformation of t to the power 4 is just equal to, my fucking screen cut off again, is equal to 4 factorial over s4 plus 1, which is equal to 1 times 2 times 3 is 6, times 4 is 24, so that's 24 over s to the 5. So we'll go plug that in. All right, let's see, got it right. So once we're done with this problem, we'll be halfway there. All right, so let's see. Find the Laplace transformation of the function. So we have f of t, and the reason why they give us the Laplace transformation is because most of us are engineering students, and engineering students are going to be using the table a lot, supposedly. So we have sine of 5t t being greater than 0, but that kind of doesn't matter. So the Laplace transformation of sine, I think I remember this one off the top of my head. It is the Laplace transformation of sine of at is equal to a over s squared plus a squared, which means that the Laplace transformation of sine of 5t is equal to 5 over s squared plus 5 squared, which is equal to 5 over s squared plus 25. All right, now let's test it out. And we got it correct. Let's go. So the nice thing about doing these is the more you do them, the quicker you get, which is why calculus students are so good at algebra, because all the time they have to do a lot of algebra to do a single calculus problem. Like an entire test's worth of algebra to go through one problem, which is kind of silly, but it's real. All right, so next question. Find the Laplace transformation. Oh, we did this one. It'll be easy peasy. All right, so I guess if you've been watching along, you want to follow along. F of, so let's start off by giving us the initial function. So f of t is equal to sine of 5t, right? So we have to build out our function. So we have from what would be the upper bounds and what would be the lower bounds for such a function, right? Upper bound and lower bound, what would it be? So in order to get the Laplace transformation, you have to go from 0 to infinity. And then it's e to the minus st times sine 5t. Don't forget the differential, which is dt. So I'll type that in. So we have O 0. So it's e raised to the minus st sine of 5t dt. The value the integral gives, so this will just be the Laplace transformation that we already did. So this will be equal to 5 over s squared plus 25. So that's 5 over s squared plus 25. And because we can't divide by 0, the domain would be anything greater than what number puts 0 at the bottom. So we can't let s squared not be equal to 25, which means that we have s has to be unequal to 5. And the way that I'm going to put that is s should be, well, it shouldn't be equal to plus or minus 5, but s would be equal to, sorry, just greater than 5 is how it's going to work. All right, I guess I have to do some more thinking. All right, s. I wonder if they'll let me do the inequality. You know what it could be? It could be that it has to be in between 5 and -5. That could be it as well. Nope. It does not fit with the equation. So okay, I don't get the domain for S then. All right, let's see if there's something in here that gives us more information in my notes. All right, let's see. So function about design. All right, A less or S equal to A. Oh, wait, okay, no, because it's not going to get to 0, and we're not working in the complex plane, so that means that it has to be all real numbers. Okay, wait, okay, yeah, I just did an oopsie, that's all. Okay, so let's see. So it's S is greater than -infinity, I guess. No, syntax error. So, okay, so I don't get it. For all we know, all we care about, S can be anything. Does not exist. No. Alright, that's... So I don't know what they want me to write here, so I'm just going to type in some bullshit. S being greater than infinity. I should at least put something with syntax errors. You know what? I'm gonna be real silly, and I'm just gonna say S cannot be equal to 5i. I can't do that either. Nothing. Okay, what would it even S? Okay, S greater than 0. I guess if it couldn't be okay, yeah, I guess that makes sense. So I'm just gonna get a similar question, and I'm just gonna. Because I already know how to do this. Because I just did it, and it's gonna be functionally the same. So so there's no point in making you go through that again. So see S T sine of 2t. All right. Actually, you can't see chat is the thing. Okay, let's see. Yeah, top chat. Is there any settings I could do for this to make it easier? All right. So let's erase. All right. So now let's see. Find the Laplace transformation of y of t equals sine of 7t. And then we have some lambda, or I guess it's not lambda. Yeah, it's just capital Y. So y of s is equal to the lambda function of sine 7t, which is just, like we've done before, I don't feel like explaining all these because a lot of this is repetitive. The process is exactly the same. It's just that doing it gives you, just lets you do it faster. So I guess I'll do for this one because we've already did the sine. But for y of t equaling, this is, by the way, this is a completely separate problem. For y of t equaling cosine of 5t, let's see, lambda cosine of at is equal to, not a actually, that said be s squared plus a squared, right? So that means that a is equal to 5, right? So then that means that y of t, or sorry, y of s is equal to lambda cosine 5t, which is equal to s over s squared plus 25. So we'll type these in, and we'll see both of them. So that's 7 over s squared plus 49. That's s over s power 2 plus 25. Doing these would have been a lot slower earlier this week, or I guess last week, because today's Sunday and the start of a new week. But it would have taken a lot slower. But with these, I could probably do these in my head right now, which is really good to show like progress, I guess, like comfortability with the topic. So let's see. Oh my goodness. Oh my goodness. Oh my goodness. All right. So we have a case of inverse lambda. So this is a bit different. Just a little. Just a little. But we have to find f of t, but we know f of s, which is already lambdaed. So f of s is equal to, and they wrote this really weirdly, but it's minus 3 over s minus 4. They wrote this so weirdly. But the situation we use this for, I'd say we kind of want to find something with this form here. We want to find something with this form, right? So we go through a table, and what do we find? That kind of something that looks like this. E to the at, right? So e to the at lambda this hoe, right? Lambda this hoe is the same as 1 over s minus a, right? So in this situation, we have our a, right? And we have a constant. So we can move constants out. So that means that, sorry, minus 1. So this is, we use the minus 1 for the inverse notation. So this is the inverse of minus 3 over s minus minus 4 is equal to minus 3 multiplied by the inverse lambda function of 1 over s minus minus 4, which in this situation would be equal to minus 3 e to the minus 4t. Right? And so now we check this. So we have minus 3 e to the minus 4t. All right. Incorrect. You got it. And a lot of people who don't do math will think that this is the hard math, and this is where, like, this is the real shit. And in a way, it kind of is. I think the universe doesn't really care about what people consider difficult math. But as far as society goes, I don't feel like this is the upper level. Because it feels complicated when you start it, and it becomes easy, right? And it might just be the problems that we're giving, and the topic itself is actually complicated, but it just gets easier. And how this feels is like how basic algebra felt, or like how adding 1 plus 1 to 2 felt. And I know that everything further, I'm going to go through all this over and over again. Because that's how a lot of it feels, right? You get something complicated, and it becomes simple. And your understanding of math increases. I think math is just such a beautiful subject. It makes me very sad that not a lot of people want to try it out or want to spend time with it. So I guess I don't have a BRB screen. I'm gonna go for a tiny bit. Yeah. Let's see. Audio mixer. So I'll mute myself. I'll be back soon. All right, I got my food and drink now. I'm gonna eat it. So yeah, I'm just gonna eat it. So I guess the way we do this is we just erase. I might try to make a video on how to do Laplace transformations, just like the basics. Uh, and if you're reading the stream, you can tell what I'm eating. And so my brother's stepdaughter had a birthday, so they brought her some chocolate cake from that. Chocolate cake in Arizona. Ice tea. Alright, so this is really my first non-gaming stream. Let's go ahead and drink to that. Nice. I don't think anyone's gonna watch this, but if they do, neat. So they brought her some chocolate cake from that. Right. So this is really my first non. Let's open up the cake. I didn't expect the mic to pick up audio like that really well. Oh, it's gonna audio loop because I have it on my phone and I'm watching my own stream. Isn't it? I didn't expect the mic to pick up audio. Alright, that's fine, that's fine. This cake's pretty nice. Okay, I don't know if I can finish it all in one sitting because it's not a slice. It's an amalgam of slices in like a container, right? I'm also looking kind of lose a little bit of weight. All right, let's see. Why did my phone ring? Give me a minute. Alrighty, chat. So I'm back from my bathroom break. Alright, so let's see. Find the inverse Laplace transform where f of t of the function. Let's do this. So f. So f of s is equal to 24 s to the power of 5, where s is greater than 0. I have really good memory in the fact that I know that we already found this as the answer for a regular Laplace transformation, so we know that the inverse Laplace transformation is the original function. So this is actually really easy. We can solve this really quickly. I'm just doing this to write it all out. But we know that this is equal to t to the power of 4, which is super convenient that we've already done it. So we can go test this one out, and we have submit. There we go. So we have, this was correct. So we have the opportunity to erase all this. And so luckily we remember everything from there. Give me a second. Just going to drop something in the Discord. I was just doing some stuff, some minor interruptions, but let's see. All right, so I have to find the inverse Laplace transformation of, let's see, f of s equals 1 over s squared minus 25. So let's see, for this one, if I were to try to eyeball it and I didn't have my table, I'd probably try to use imaginary numbers for this, which might actually work. Wait, that. Wait a minute. Ooh. All right. So, I. Ooh. Wait. I need to think about if this is a good idea or not. All right. So not only do I think this is a baller move, I also think this was the intended move. But this should be equal to, if you take the constants, we will say for a being equal to 5i. So we have, if a is equal to 5, give me a sec. All right. So the so here we're gonna say that 1 over s squared minus 25. So complex numbers are still constants. It has a letter in it, but it is a constant. So we can logically, this should extend. Complex numbers tend to have property where they're just really fucking useful. So go here, right? This will be equal to, what is it? 1 over 5i Laplace transformation minus 1 of 5i over s squared plus 5I squared So because there's a constant up top, we know that it has to be equal to sine of So I guess we'll go check if this is correct. Maybe it is, maybe it isn't. I'm worried that this won't be correct, but maybe it will be. Maybe it will be. Let's test it out. Let's test it out. So we have sine of 5I t So there's a syntax error here. All right, so this isn't going to be the way to solve it just because this doesn't fit in the syntax of the program. So we can't use that. Even if it is right, we can't use it. So I guess I'll just have to scour the paper. All right, so let's see. So we have f of s equals 1 over s squared minus 25. Oh, wait. Oh, wait. Oh, I forgot. Oh my god, I forgot. So there's this property. Okay, okay, this is a lot easier now. So this is equal to 1 over, you have to complete the square. Let's see. What's down here? Okay, never mind. Never mind. I still don't have it, but all right. Well, let's see. Okay, I don't have the solution here. I don't. Okay. You know what? There's a help video. We can watch it and try to solve it. So let's see. Does it show up on stream? We do. It does.
We're asked to find the inverse Laplace transform of
I think I'll mute my mic for this because I feel like I'm gonna have double audio on it.
big F of s, which will give us the function f of t. For this example, we're asked to give f of t as an exponential function as well as a hyperbolic function. And actually, in our homework system, they want f of t as an exponential function, but again, we will show both. The first step is to begin with big F of s and find the inverse Laplace transform of both sides of the equation. So we'd have the inverse Laplace transform of big F of s equals the inverse Laplace transform of 1 divided by the quantity s squared minus 16. Now looking at the table of Laplace transforms, because we're given big F of s and we're trying to determine little f of t, we'll be using the table in this direction here. So let's see if we can recognize the formula we'll use.
So, okay, so let's see. The hyperbolic function of not cosine but sine. Right? Okay, so sine. All right. So this is given from the paper that I have, the table of values. So we know that this would be equal to sine of, so it's a over s squared minus a squared. So in this situation, we have a will be equal to 5, so it's 1 over 5. So right. All right. So now we have so this should be the answer now. Let's see. So we have sine h 5t over 5. So we'll see here. Yes, so let's go. All right. So that is question 11 out of 12. This will be the last question. All right, so let's see. We have, this one shouldn't be too difficult. It's f of s is equal to 5s minus 24. S squared minus 10s plus 24. All right, so for this one, I think we can kind of complete the square with this one. So this is equal to, let's see, s minus 5 squared at the bottom minus 1 all over s minus 5 times 5, then plus 1. So this one's kind of nice. So this one's kind of nice because we could just split this up again. So go, I guess not again, but we have 5 times s minus 5 and then minus 1 plus 1 over okay, I'm losing the plot. I'm losing the fucking plot. Okay. S minus 5 squared minus 1. All right. So we split everything up into these two, which can themselves be Laplace transformationed. So the Laplace transformation of f of x, or f of s, is going to be equal to the full inverse Laplace transformation of... My words are wrong. Don't look at what I'm saying. Look at what I'm writing. Jesus. Right? So we have this is equal to 5 times the Laplace of this. So where s is s minus 5, we have, I believe it's t minus 5. Let me check my paper just to double check. So the shifting theorem. Okay. Okay. So this means that we have e to the... Right. So, okay, wait. Let's do it from down here. Okay. So this is equal to 5e to the 5. So it's 5e to the 5t multiplied by whatever the normal inverse Laplace transformation this would be if instead of s minus 5 it was s, which is s over s squared minus 1, which is 1 squared, which would be cosine. So it'd be the hyperbolic cosine function of t. Easy as cake. Plus the hyperbolic cosine function of, plus the hyperbolic sine function of 1. Sorry, of t as well. Fuck. All right. So, okay, wait. So, okay, my algebra with this on is actually a bit wrong. Let me clarify this. Let me fix this up. So, because, yeah, let me just... All right. So for this one, it's going to be e to the 5t. All right, there we go. Everything's organized just about right. Let me check. All right, so we have 5 cosine of hyperbolic cosine of t plus hyperbolic sine of t, all parenthesised of e to the power of 5t. So, submit. Let's fucking go. All right, so that is all the problems of this homework assignment here. All right. Let's see, is there any more homework assignments? So we did the Laplace transformation introduction. So we'll do Laplace transformation, shifts, and step functions. Okay. All right. I love my open math. My open math is amazing. So there's, oh my god, there's 20 questions. Is there any information that gets leaked if I show this? I guess not. Like, I guess there isn't. Right? There's no information that's... No, there's no information that leaks. Impossible. I guess it's... No, I'm not gonna do it. I'm not gonna do it. I think I'll do the rest of this offline, but at least now I have the ability to do this record and stream.